Okay, so we're going to talk about the second kind of product, which I already hinted at before. It's called the cross. Yeah. Okay. So it's called the cross product. And somehow in your brain, just realize that the answer is not a number anymore. When I do this, the result is a vector. So it's take two vectors, cross them together, and I get a third vector. And where does that come from? Well, first of all, this is only in 3D. So if we do this, if we try to do the cross product of two vectors in 2D, you'd have to extend it to 3D because the answer is not going to be in 2D anymore. But the goal, and this is one of the goal, is to have this property that if I did for ij and k, these are the base ones that we can base, that literally base everything off of, is we want these things to happen. We want to do I cross j. We write it as like a x, but you read it as a cross, equals k. And if you try to do this in 3 dimensions with your fingers, so if I is the pointer finger and j is the middle finger, then your thumb is k. So I don't know if you can sort of see that. But the idea is crossing is kind of like you're trying to maintain the right-hand rule here. So you do I and you move it towards j, and the resulting vector k is pointing up. So it'll be reversed if you tried the left-hand rule, which we're not going to do because everything's right-hand rule, right? So I cross j is equal to k. Now, if you wanted to reposition your fingers so that you have ij and k, in order to get the same sort of right-hand rule, is you would want j cross k, and it turns out that that is equal to I. So if you can somehow reposition your fingers where it's like one on the y-axis, one on the z-axis. So you have y and z, cross them together, you get I. Now the tricky thing is, in order to get j, you have to go k cross I, and that will give you j. So it's kind of like I to j gives you k, j to k gives you I, and then k to I gives you j. And so in all 3 of these cases, you cross these 2 together, and you've got a vector that's perpendicular to both of them. Same thing here. X, y, and z axes are all perpendicular to each other. So this maintains perpendicular to each other and the right-hand rule. And the little shortcut for this is, usually put like a little plus in the middle, that if you went I and you crossed it to j, you would get k. And if you went from j and crossed it with k, you'd get I. And if you go k and cross it with I, you get j. Now, at the same time, if you reversed things and said j cross I, so if you try and do this with your fingers, then they get reversed. So instead of wrapping this direction, in order to maintain the right-hand rule, I have to turn things upside down. And when I do j cross I, that time, my thumb is pointing down. So this turns out to be the exact opposite of that vector, so you end up getting minus k out of that. And the same thing with any of these. If you reposition your fingers, let's see, if I do k cross j, I would get, my thumb would be pointing in the opposite direction, so I get a negative sign. And I cross k, just to reverse all of them, you get minus j. So if I cross in one order, so I coming first gives me k, but I coming second gives me minus k. So you can see you can't just do cross product in any order you want. You'll end up getting the opposite sign. So key here, cross products not commutative. Now that works for I, J, and K, but how do you do this in general? Well, we could go through the derivation, or I could just sort of give you some examples. We could work through it. I think at some point you can read through a lot of this stuff, but maybe for today, because we're already doing quite a lot. That if I wrote, and I'll just tell you what the answer is for today, and maybe we can come back to it later. But if we wrote these things out, W1, W2, W3, so those are the components. And I wanted to do V cross W. Well, I could write this as IJK, so V1I, V2J, V3K, and then do the cross product and distribute everything out, and then use the fact that the cross products have these rules for IJK, they have these rules if you do them in the opposite order, get all the negatives in the correct spot. It turns out, this is kind of a crazy thing, that you end up getting, make sure I get this in the right order, V2W3 minus V3W2 in the I direction. That's that. The next one turns out to be V1W3 minus V3W1 in the J direction. And I get V1W2 minus V2W1 in the K direction. And this all just comes out from the properties on the previous page, plus the distributive property, plus making sure I get the minuses all in the right place. And it's kind of a nightmare. Now, in Math 103, some of these things kind of look away. So I got V2 and W3, and then I have V3 and W2, and they're subtracted. This might be a bit of a stretch, but it comes out of looking at something like this. And I'll tell you what the name of it is in just a second. Where I write these things in rows, and you can see you've got I, and then this thing down here is like V2 and W3 and V3 and W2 subtracted. So if that rings a bell at all, this thing is called a determinant, and all of these things are called like cofactor expansions of the determinant. Now we're definitely going way back here, but from Math 103, it's like I, well, I'll write it like this, V2, V3, W2, W3, that little subdeterminant in the I direction. I'm using the word determinant, subdeterminant. For the J direction, it turns out that it's minus when you pull out the parts for J, so it'll be V1, W1, V3, and W3. And then for K, I pull out this little subdeterminant here, V1, V2, W1, W2. So you can see the only reason this works in 3D is this determinant like this only works in 3 dimensions. And so it comes out, there's all sorts of properties that come out of this. And so you can either remember it as this formula, or try and do this distributive property here. All right, that's a lot of talking. Let's do some examples here. Go back to the one we had. So V is 1, 2, 3, 2, 3. I have to put all the gaps. And this is 1 minus 1, 1. So V cross W. I write it in this determinant form. I will get 1, 2, 3, and 1 minus 1, 1. And these, I mean, they do take a little while. I have to do a subdeterminant for I, where I cross out everything that's not I, and I get 2, 3, minus 1, 1. For J, it has this built-in negative in here, where I cross out everything except for that, and I'll get 1, 1, 3, 1. So I'm crossing out this, and I'll get these pieces here. And the same thing for K. cross out all this stuff, I get 1, 2, 1, minus 1. And if you had 103, good luck. If you haven't, then this symbol right here just means to cross multiply and cross multiply back the other direction and subtract those answers. So 2 times 1 minus 3 times minus 1. And that'll be in the I direction. Now subtract off 1 times 1 minus 3 times 1 in the J direction, so it's these two and these two. And then here is 1 times minus 1 minus 2 times 1, so products in the K direction. So if I do this correctly, this should be 2 plus 3, so that's 5i, minus, this will work out to be 1 minus 3, so that's minus 2, so minus and minus 2 is plus 2. And then this last one, minus 1, minus 2, so minus 3 in the K direction. And that will be V cross W. So you end up getting a vector. So it's key. In the homework, when you're doing this stuff and you work it out and you get a number, you're like, I didn't quite do it right. So there's that. If based on the properties, if I did W cross V in the other order, all it does is it reverses it. Minus 5i, minus 2j, and 3k. And you can see that if you just work this back out, that instead of the rows being like this, the second and third rows get reversed, because the W and the V are in the opposite order. And way back in 103, you might remember if you switch 2 rows in a determinant, it changes the sign. And so that's the same sort of thing. So it all sorts of connect back up together. So there's that. What else to notice is if I did V, what happens if I do V cross V itself? So if I did the dot product of V and V, I got the length squared. What happens if I do the cross product of V and V? Okay. Well, let's just try it here. IJK, 1, 2, 3, 1, 2, 3. So according to the formula, I would cross out all this stuff and I would get this 2, 3, 2, 3 in the I direction. So all the stuff that's left. The J I subtract and I would have 1, 1, 3, 3 in the J direction. I just take all the stuff that's not J. Okay. I get 1, 2, 1, 2. Now, if you do all these little subdeterminants here, 2 times 3 and 2 times 3, and you subtract, you have no i's. For J, same thing. It'll be minus, I guess, minus 0, J. And same thing for K. So I end up getting 0, 0, 0 is my answer. And I'm not sure I've written this down yet. Sometimes the book will write this as the 0 vector. So it just means the vector, in this case, 0, 0, 0. So I took the cross product of these two things and I got all zeros. And that's a property. If you take the cross product of a vector with itself, you get the 0 vector. So what does that mean? Well, if your eyes haven't glazed over yet, properties of the cross product. And one of them is, it turns out, that if you do the cross product and you get the 0 vector, so now you have two, no, I should use B and W. If I take the cross product and I get 0, 0, 0 as my answer, turns out that that doesn't mean that they're perpendicular before, it actually means that they're parallel. So that's nice. If you want to know that two things are perpendicular, the dot product is 0. If you want to know if they're parallel, then that means that the cross product is the 0 vector. What else? I'm not going to derive this, but it turns out that if you draw a picture here, where this is V and this is W, it turns out that if you take V cross W, and you take the length of that, it turns out that you get the area of a parallelogram, which is gotten by extending out B and W. I don't think I'm going to end up proving that one, but that's a nice thing. It gives you more geometry. If you take two vectors, you take the cross product, then take, because that'll be a vector, you take the length of that, it'll turn out to be exactly the area of parallelogram. And another way to see that is also if you take the length of V cross W, it turns out that, very similar to cosine, it turns out that this one is the length of V times the length of W times the sine of the angle. So whereas the dot product is related to cosine, the cross product is related to sine from that property right there. So those are sort of the main properties that you'll need to do the cross product. And I don't know, the rest is sort of like looking at a bunch of examples, and maybe we'll do one more that has numbers in it, and then we can see if you have any questions about this stuff. So let's try one more. So V is -215, W is that one there. So sort of sum up pretty much most of the stuff from the morning here. Let's do a lot of these things. So the length of V is the square root of each of these guys squared together. So it'll be 4, or -2 squared plus 1 squared plus 5 squared, 25, 26, that'll be 30. So square root of 30. The length of W, maybe we can just do that in our head here. 1 and 9 and 1, so that's 11. W. Length of W. The dot product between these two things, the dot product of V and W. I multiply the first two things together, and that gives me 2. I multiply the second two things together, that gives me 3. I multiply the third two things together, and I get 2 plus 3 plus 5, which is 10. So if I wanted to know the angle between them, the cosine is the dot product of those two things together, so 10, divided by these two numbers multiplied together, square root of 30 times the square root of 11 on the bottom. And so you could take the arc cosine of whatever that number is, and that would give you the angle. If I took, and I wanted to do a shadow, if I took the projection of V down onto W, so I draw W and then I draw V and I do my light bulb shadow or my projection. Turns out that this formula here has W, it's a scale version of W. So I know that my W vector has to go there. What goes inside is the dot product, which is 10, divided by the length of W squared, which is 11. I know it's a lot to remember there. That's V dot W over the length of W squared. That's the number, and then you just multiply that by the vector by W. So you get negative 10 11ths, 30 11ths, and 10 11ths is your projection formula there. So that's sort of a lot of the dot product stuff in there. For the cross product, the cross W, take I, J, K, minus 2, 1, 5, minus 1, 3, 1. And then I have to work out all of these little subdeterminants in here. So I part will be 1531 in the I direction. Minus, has built-in minus here for J. So minus 2 minus 1, 5, 1. And then for K, it's this little dude down here, minus 2, 1, minus 1, 3. So if I do this, if I want to screw this up in my head, so 1 minus 15. So we multiply the diagonal, then the back diagonal, minus 14. That'll be J. It's got the built-in minus, so that's minus 2 minus a minus 5. So minus 2 plus 5 is 3. And then for K, I'll get minus 6 and minus a minus 1. So I think that works out to be a minus 5. I guess if I wanted to do the length of that, that would be the square root of 14 squared and 3 squared minus 3 squared, everything's going to be positive, minus 5 squared. Go back to the multiplication tables. Do 14 times 14, 4 by 4, 6, 5, 0, 196, right? So it's 196 plus 9 plus 25. So that's 205 plus 25. So square root of 230. And again, what that represents is if I was to draw V and I was to draw W and then sort of extend them out to make a parallelogram, put that right there and do the area of that part in there. So that one slide right there really brings together all the stuff that we have: dot product, angle, projections, cross products, areas. And I know that that's kind of a lot, but it is fairly formulaic. The numbers are small. They're all 3D. So hopefully that can give you a good start on that homework. So those two I think are due tomorrow. But with that, let's see if you have questions about anything from last night on 10-2, which is again due at 1 o'clock. If you went, oh crap, we just had a test, I didn't realize we had homework, well, it can take a little more time. Turn it in sometime today is all that I really care about. But let's see, do you have questions on 10.2? Start there.
Sir, can you go over question 30?
Okay. So now we're talking about forces here. We have these two cables here. One of them is called theta. It's called phi or p, I suppose. And in 30, it says the angle is 60 degrees and phi is 30 degrees. And basically find all of the sort of forces that are going on in there. And now you have to basically just go back and look at sort of basic force diagrams, I suppose. So I draw this out just as a point. So there's my weight. I'm going to have a force that comes from gravity, and then I'm going to have a force that's imposed up the chain. Maybe we'll call this one F1. And I'm going to have a force that's imposed up that one there, like that. And we know that the object is not moving, so called static, which means that all these guys are going to have to balance each other out. If there was no balance, then the object would be moving. But because it's not moving, that means that the gravity is balanced by these two forces that are adding up. So what I need to do is just write out all of the component pieces here. And so let's see. So the force due to gravity as a vector, it's just gravity down. So we just have a vector that's pointing down, and that is minus 100. It's 100 pounds. So the force vector is just pointing straight down. So assuming up is plus and down is minus, it probably won't matter. You just have to remember which one is this. So we assume down is minus, then we get that this is the force vector pointing up, just gravity. Now, how about the force on 1? So this vector pointing up this direction will be, well, I know what the angle is here. Let's see. So this one is 60, right? So the angle for this one, I wanted to get this vector here, then I think I'm going to get these things in the right. So this one is 30. So if I did this vector here, so if I want to make sure I get the angles right, I want.
Sir, I think both of these angles are the same. They're both 60 degrees.
Crap. Thank you. Thank you. I was reading. I don't know what I was doing. I was mixing 29 and 30 together. So if this one is 60 degrees, then I don't know. I'm sort of more used to, which one do I want here? 60 for the y component. That one's 60. This one's 30. So I don't know how you want to do it. This is, if I did this as cosine of 30 and this is sine of 30. I don't really want to use the 60 just because I like the cosine to be in the x component here. So I think that angle is probably cosine 30, sine 30, according, and then some number in front. Maybe call it M1. That's that vector. The second vector here, I kind of want to base everything, I think, off of 30. I think the second vector is, in order to get the signs correct, I want this to be cosine of 150 and the sine of 150 degrees. So I'm sort of basing it off of the angle in order to get the signs to be correct. So I think that this is correct here. But if they're all going to balance out, then what that means is that the x components are going to have to end up coming together to be 0, and the y components are going to have to come together in order to be 0. So again, yeah. So what is it? Write that in your statics class. I don't know if you've had statics yet or not. But all of these three things are supposed to balance each other out, again, because it's not moving. So that would give me that M1 times the cosine of 30 degrees plus M2 times the cosine of 150 degrees. That's going to have to balance out to 0. The component in G is 0. So I add all those up and I get 0. If I add up all of these, I need that M1 times the sine of 30 plus M2 times the sine of 150 minus 100, you have to be 0. Why did I write 30? Yeah, 30, yes. M1 30, M2 sine 150. Right. So basically what I've got is I've got 2 equations and 2 unknowns, M1 and M2. And you can probably solve that out to get, let's see, cosine, what is the sine of 30? we get like lots of these square root 3 over 2 in some. We get halves in some of the other. The cosine, well, the cosine of 30 is square root 2 over 2. The sine of 30 is a half. Sine of 150 will also be a half. So, I mean, the second equation there says that m1 plus m2, or m1 over 2 plus m2 over 2 has to be 100. This is a half. This is also a half. So I know that at least they have to add up to be 200. And if I substitute that, find that substitute into the first one, I think, or I mean, really honestly, just look at the symmetry to this, right? If they're the same angle, then you can see that M1 has to be equal to M2 because they're sharing the load both 60 degrees off of it. So that's just by symmetry. So if they have to add together to be 100, that means that M1 and M2 each have to be equal to be 100. So you could then take that, plug it back into your equations up here in order to get exactly what F1 and F2 are. So just sub that. So these are a little tricky. You have to figure out exactly what angles you're talking about. Maybe I shouldn't have used 150. Could have used probably using some identities. I could get like negative 60 maybe. I don't know. I'd have to think about it. So try and get all the angles based off of some general thing. So this is 60, this is 30. So I could have also, instead of putting the 30 there, I could have put the 30 there. So that would be 150 to get over to here, or maybe, I don't know, maybe I put the angles in the wrong place. But, there you go. It's not the cleanest presentation, but that's the idea. So it's basically 100 in this, but putting it again in 30 degrees this way and get 100 going off. And I think if you put all the angles in, you can see that this one's going to be over and up, and this one will be back and over and up. Hopefully that's helpful.
Sir, would you be all right with us treating that like a statics problem?
Yes.
And just doing engineering notation?
I don't care.
Thank you.
Sir?
Yeah.
How do you know that like F1 is like how did you know the formula for F1 is what I'm asking?
Well, I mean, every vector can be written in a couple ways, right? So you can write it as V1, V2. You could write it like that. Or you can write it as the length of V, which is kind of like the magnitude, which is not a bad idea to think of, magnitude of a vector in the magnitude of the force. So, you don't use this enough, but you probably should because it's like that. That makes sense. And so you might have F1 and F2. Well, it depends on which angle you use here to figure this out. But I'm using this formula right here. So it's basically the magnitude of the force. In this case, it's like magnitude 1 for force, and magnitude 2 for the second force. And then figuring out the correct angle to get cosine and sine. As it's drawn, you might want to use sine and cosine in the reverse order. I kind of don't like that just because cosine really should be affixed in your head. As that goes with X, sine goes with Y, just from the unit circle. So that's a long answer to, I'm using the second version of the vectors as opposed to the first. And I don't know, in Nichols, they're probably in static class are like, just forget what they told you in Mallory. Here's the force diagram, the statics diagram. Just do it like this, and it works out. And then I'd go back and say, let's draw this again. Is this the same? Yeah, all right. It's technically the same, but you guys make it so much more complicated. We don't want to let you in all our secrets. If math was easy, everyone would be doing it, and that'd be a dangerous place. All right. What other questions? Any other questions on 10.2 or stuff we did today or general comments about life? Apparently we'll be back in the fall, so that'll be an interesting experience. You know, I think they're putting up plexiglass in front of the rooms. They're going to space it out where it's going to be sort of a hybrid. Some people all online, some people partially online. I don't know if they're going to do like you come to class Mondays and you come to class Wednesdays, and then we all meet online on Fridays. I don't know. We live in uncertain times. My son's going to Virginia Tech, and I think he's just happy. He's like, I want to get away from home, go start my program, get to college. So, I don't know. You guys are young and tough. You'll be fine. It's the old guys. So wear your mask. All right. If there's no other questions, I'll let you guys go. You can work on the homework. I know it's kind of a lot. You forgot to start this homework. Get started on it. I think you still have enough time to finish by noon or by 1. If you need a little more time, just let me know. Otherwise, 10, 2, and 3 are tomorrow. You'll have a good day. Pretty weather here in Virginia so far. So take it easy.
Thank you, sir.
Have a good one, sir.
See ya.